Welcome, everyone. I'm Kevin Cohan.
And I'm Ed Marquez.
In the keynote, we heard about some amazing examples of how engineers and scientists around the world help navigate the challenges brought on by the pandemic. A disinfecting robot developed in just 10 days, new ventilators developed in only 47 days, and professors transitioning from teaching in classrooms and lecture halls to remote learning almost overnight.
And as Rich described, MATLAB and Simulink played a role in all these stories. So how is it that these products can have such an impact on the work of so many engineers and scientists? Well, much of it is because thousands of people at MathWorks continuously work to improve the capabilities of MATLAB and Simulink with 2 releases every year. Over the next 25 to 30 minutes, Kevin and I will share some, but clearly not all of these new capabilities. Our hope is that you'll find at least a few that you can apply to your work.
The talk's divided up into 3 main sections. The first is something that Rich highlighted in the keynote, capabilities that allow you to focus on your work, not the tools. The second is about collaborating with others. And finally, taking your ideas from concept to production. One of the primary ways that MATLAB and Simulink help you to focus on your work is by allowing you to do so at a higher level of abstraction. When typing commands in the live editor, for example, as part of data exploration, contextual hints make it easier. You can even access the documentation right at your fingertips. Results are embedded directly in your script, and you can interact with them. The MATLAB code that corresponds to that interaction is automatically generated. You can even update your script with a simple click. By combining code and results in this way, you can explore without a lot of context switching. Now, in some cases, you may not be sure exactly which technique, plot, or function is needed. For these situations, we make coding optional. A live editor task is a small app that can be inserted directly into your script. It allows you to interactively explore different options without writing code. Let's see how these work by looking more closely at a new task introduced in 21A, Create Plot. This task allows you to interactively explore different visualizations. I'm using Fisher's iris flower dataset. Let's start with a simple plot. Now, if I choose scatter, I need to add a second variable, so I'll choose petal length. Note that labels are automatically added to the plot. Finally, I'll choose a swarm chart and make species my x variable. Now, this is a really great way to try many different plots quickly. Available options are displayed right in the task. So you can do all this without writing code. But when you need it, the code is automatically generated for you. This allows you to replicate and automate your work. So you're programming, but without the coding. There are over 24 live editor tasks available for data preprocessing, working with tables and timetables, control system design and predictive maintenance, and a number of others. All designed to help you focus on your work and not the code needed to get answers.
With Simulink, the goal of our work is to help you spend as little time and effort as possible to build and edit your models. We want you to edit at the speed of thought. Simulink makes it quick and easy to sketch out a model. You start by just drawing in the canvas, size and snap to other objects, make connections quickly, rename ports as you create them, and you add connections anywhere. Just because you create models quickly, it doesn't mean they can't be clean, readable, and well documented. It's really simple to add information to your model by just dragging and dropping or copy-pasting in the canvas. And Simulink helps you resize blocks to show ports and parameters clearly. We heard many of you like to work with a keyboard. Well, we improved that too. You can move around in your model with the arrow keys and toggle to select one or more elements and place them where you want them. And you can easily edit the text on model elements with F2. That works with all of our editors. That means Stateflow too. Speaking of Stateflow, it's also easier to edit your decision logic. You can insert components right from the canvas, just like in Simulink. And when you need to reverse transitions in your logic, you do that with just one click. We know that you also value readability of state charts, so Stateflow now lets you edit the color of the syntax highlighting for data to make your logic even easier to understand. With all these improvements, our goal is to eliminate busy work by automating things that we can do for you. We also want to bring you the capabilities that you need right when you need them. That's the value of the Simulink tool strip, that it shows you features and menus based on the work you're doing and elements you select. And it makes over 1,100 capabilities way more visible and accessible to you compared to the old menus. One powerful example is the formatting capabilities that the tool strip exposes. Now it's a breeze to set the format and style of your model to what you need. As you saw, Simulink makes model editing simple to help you make the complex things possible, while you stay focused on your work and not the tools. Fast model editing is important, but we know how much you appreciate fast simulations too. The good news is that Simulink runs models faster out of the box. One example of that is co-simulating components on multiple cores automatically. If we take this model and execute it serially, it would take almost 30 seconds to simulate. With multi-core simulation, the model would run like this on multiple threads, and it simulates in about 10 seconds with this parallel execution. That's almost a 3 times speed up for this simple example. So if your design contains model references in accelerator mode, S functions, or co-simulation FMU blocks, then Simulink automatically runs the model on multiple threads as long as there's a performance improvement. This is great if you're working on a large system with many components from different people or teams. Another improvement for speed is Simulink Cache. These files are generated automatically when you simulate models in accelerator or rapid accelerator mode, or when you generate code. The great thing about these cache files is that you can share them across teams to skip unnecessary model rebuilds for simulation and code generation. This can speed up workflows like continuous integration, where your team members commit design changes to a source control system, then the continuous integration system pulls those design changes and archives the cache files to a build archive. So when it's time for you to do work, you pull the design files from the source control system and you get to reuse the cache files generated by other team members. And they get the same benefit from you. Ultimately, this is about you speeding up team workflows and getting to your results faster. For many of you, the systems that you design may require working with vectors. If you're doing array operations with for each subsystems, those iterations also run in parallel by default when you simulate in rapid accelerator mode. Simulink automatically profiles your model on the fly so that you don't have to, and it runs the for each subsystem in parallel if it detects performance gains. Speaking of array operations, Simulink does that faster too with hardware acceleration using SIMD instructions. This basically enables vector math operations in Simulink. So instead of operating on one array element at a time, you operate 4 or 8 elements at a time depending on your hardware. These are some of the ways in which Simulink runs faster out of the box, with no changes to your models. The goal is to help you save time as you explore the design space and run large simulations. Speaking of massive simulation jobs, be sure to check out the parsim and batchsim commands to set up and run multiple simulations in parallel.
MATLAB is fast and getting faster. We've seen an average speedup in customer workflows of over 2x compared to 5 to 6 years ago. And you can get these results just by installing the latest version. No need to make any changes to your code. More specific areas are also targeted for performance. Graphics rendering examples saw a 6x performance gain. Indexing operations saw a speedup of anywhere from 2x to 25x. And sparse operations had a 4 to 5x improvement. All of these results are based on specific test cases. The details are available in the release notes. Here's an example for sparse in 21A. Drilling down into the release note, you can see the measured improvement, the code we used, and the hardware we ran it on. This will allow you to see the specifics of the examples and better determine if you might see similar results with your code. Deep learning is a specific area where performance is critical, and things continue to get faster there as well. Network training had a 1.6x improvement when using multiple GPUs, and inference got between 2.5 and almost 3 times faster for CPU and GPU hardware, respectively. Okay, let's pivot from performance. While live tasks can make coding optional, we continue to make programming in MATLAB easier for those times when you are coding. Consider this function call, which include multiple name-value pairs. It can be hard to tell which ones are options and which are values. particularly when the values are strings. In this case, we have name-value pairs for setting text type and encoding. Starting in 21A, you can use this very natural name equals value syntax, which can be easier to write as well as read. Now, just to be clear, your code will continue to run if you use commas to separate name-value pairs. But now, when calling any function, whether it's one of ours or one you've written yourself, you have the option to use this new name equals value syntax. Let's consider another example. Have you ever tried to write code to search for and match a pattern in some text? The code was not likely very straightforward. I encourage you to look at the new pattern object released in 20B. Let's look at an example. So you start with a string, as shown here. Then you define the pattern that you're looking for. In this case, we're looking to pull out our release name. So to do that, we need the letter R, followed by 4 digits, then followed by either the letter A or the letter B. We can then use the extract function to pull that pattern out of our string. So in this case, 2 release names were found. So these are 2 great examples of how the MATLAB language continues to change to make coding easier.
Earlier, Kevin showed how you can use live tasks to visualize your data. With Simulink, you also have the tools you need to analyze and gain insight as you explore. A new way to do that is with the record block, which helps you visualize and log data to multiple locations from the same interface. This gives you a convenient replacement for the 2 workspace and 2 file blocks. And the same data is available in the Simulation Data Inspector for more analysis. Now, I want you to imagine that you're working with maps or string data in Simulink. How do you analyze that? Or how do you look at the relationship between 2 signals? Or compare signals between simulation runs? The answer is Simulation Data Inspector. Yes, this has been around for a while, but we keep adding capabilities to make it more powerful and flexible for you. If you're working with maps, maybe for automated driving, you can use GPS coordinates to display location on a 2D map. When you need to analyze many signals at once, you can stack them in the same subplot using sparklines. When you need to visualize relationships between signals, you can view them as lines or scatters with XY plots. When you need to share the results, others can replay the data without rerunning the actual simulation. And you can also share interactive HTML reports. And when you need to compare signals across simulation runs, you do that with just a few clicks. All of this is there to help you analyze simulations quickly, and you get all these capabilities out of the box without writing any code. For those of you who do need to write code to automate analysis, then the Simulation Data Inspector API is the way to go. Once you've analyzed your work, others may need to look at it too. Have you ever shared a model with someone and then you had to write a really long email explaining what it's doing? You don't have to do that anymore. You can just use dashboard blocks to tune and monitor simulations without having to go deep into all the details of the system. You focus your attention and interactions to the parts of the model that matter the most to you. You can even convert dashboard blocks into a panel, and that gives you access to the dashboards throughout the model hierarchy. That's a huge time saver for testing and debugging different levels of your model. You can minimize a panel when you're not using it, so it stays visible but takes up less space. So, now that you know about these, you can use them for your own work, or you can be nice to your colleagues and send them one of these instead of one of these. Maybe they'll return the favor one day.
Sharing scripts can have similar issues, where it might take some time and effort to explain to others how to run your code. One option is to add interactive controls, like the ones shown here. This allows someone to easily modify parameters. You define which values are legal, and those are the only ones they can choose. And if you hide the code, the script becomes a simple app. Previously, when you added one of these interactive controls, you needed to manually enter possible values in a dialog like this one. Starting with 21A, you can associate those values directly to a variable defined in your script. This makes it easier to control the list of values. Sometimes you need to simply share the results of your analysis. You can add formatted text, equations, images, and hyperlinks directly to your script, enabling you to easily document as you go. Your script becomes your report. And if you'd like to customize the look and feel of your script, perhaps based on some standards for your organization, you can now programmatically control the fonts, including the style, size, and color. If you've got animations as part of your script, playback controls appear within the figure after the animation's done playing. This provides the ability to replay the animation without having to rerun the script. You can also adjust the playback speed. Okay, so this last section was about focusing on your work. As projects evolve, they often grow in both size and complexity, and typically involve more people. So let's spend a few minutes on some new capabilities to help you collaborate with others. Many organizations are adopting a version of this Devops framework. Within this framework, we know that you use many different tools to get your job done. MATLAB and Simulink can integrate with these, including other languages, source control and continuous integration servers, cloud platforms, as well as data platforms. The MATLAB interfaces with C and C++ have had many enhancements in recent releases, as have our interfaces with Python. To learn more, consider the session later in the conference on how to use MATLAB with Python. You can also use MATLAB with Python-based frameworks for deep learning, either via the ONNX standard or via targeted importers, including one for TensorFlow. As the different frameworks in the ONNX format evolve, we continue to enhance these interfaces, supporting more layers and different file formats. And you can do deep learning directly in Simulink with image classification and network prediction blocks that can simulate and generate code for deep learning models.
With Simulink, you can reuse existing functionality from other languages and tools. Our developers work hard to make Simulink the ultimate simulation integration platform, the place where you bring together large models made of many components and systems. In the latest release, you have more options that make it easy to integrate C and C++ code into your models. The C function block helps you in use cases where you need to call multiple functions, allocate and deallocate memory, pre-process or post-process the external code, and work with persistent data. If you just need to call C or C++ functions from external source code and libraries, then the C color block is the simple way to do that. In addition to the simplicity, one of the advantages of the C color block is the tight integration with our other tools to verify and implement your models that include external code. And in the latest release, we added the Simulink code importer, which is a user interface that helps you create a Simulink library of C color blocks to bring custom code into your models. The Simulink code importer guides you step by step to import the code. It automatically analyzes the code. And on the other side, you get a Simulink library of blocks that behave just like the code. With Simulink, you can integrate more than just C and C++ code into your models. FMU import and export have been around for a few years to help you work better with components from other tools. To learn more about integrating external simulation components with Simulink, consider joining this session later in the conference. Our goal with these Simulink investments is to give you the platform where all types of models come together to help you design and analyze systems of systems. Now, think for a moment about how you collaborate with others as the complexity of your work increases. Have you ever thought there has to be a better way? If that's you, I want to tell you about projects, because projects help you organize, manage, and share your code and models with a single environment and interface that works with both MATLAB and Simulink. There are a ton of advantages when using projects for your work, like automatic environment configuration, source control integration, dependency analysis and management between files, ease of sharing and upgrading, and a lot more. One of the latest updates is the ability to automate merging branches that have changes in different subsystems of the same Simulink model. This can help you automate workflows like continuous integration even more. And this also makes collaboration a lot smoother. Projects also simplify the process of sharing your work. You can generate reports and create a separate project from the dependency graph when you want to share the details of a subset of your design. You can even collaborate with colleagues using older Simulink releases because you can now export an entire project and all its files to a previous release with just one function. When you need to collaborate with other groups or suppliers, you may have to protect your IP or intellectual property, and protected models are the way to do that in Simulink. Now, when you create a protected model, you can package one project file that contains all artifacts, like test harnesses, data dictionaries, all the things your supplier needs to open and simulate your protected model while keeping your IP safe. Another capability that helps with complexity is the model comparison tool. We improved this one significantly to make it easier to understand changes and merge choices between models. And the comparison reports you export also make it easy to understand changes by searching and zooming on pictures in HTML, Word, and PDF reports.
Most MATLAB users create scripts and functions using procedural programming, but MATLAB also includes fully featured object-oriented programming. By creating well-defined interfaces, you can manage code complexity and more easily collaborate with others on large projects. A class is a fundamental structure in object-oriented programming. You can explore class structures using the new class diagram viewer. Properties, methods, access attributes, and other information can be viewed in the inspector pane. You can drill down into the source code for a specific class. You can also share proposed designs with others, either as a class diagram file or as a static document. This will allow you to explore and collaborate on complex designs. Okay, so we've seen new capabilities for focusing on your work, as well as collaborating with others to include and leverage their work. This final section focuses on taking your ideas that last step to production implementations. This requires creating robust designs, which requires robust testing. You can use testing frameworks in MATLAB to help you write and execute tests and run those tests on continuous integration servers for both MATLAB and Simulink. This allows you to automatically test and verify MATLAB code and Simulink models, and then detect integration issues early. You can run MATLAB and Simulink on your own CI server or use a cloud-hosted CI service if your project is shared publicly. To learn more, consider the session later in the conference on continuous integration with MATLAB and Simulink. Now, when you're looking to share and deploy MATLAB code, algorithms, and models to enterprise and production systems, you have multiple options available. One path is to develop a custom MATLAB app using App Designer. You can create professional apps without having to be a professional software developer. This app is a good example. The side panel includes HTML, JavaScript, and CSS content. There are numerous ways to interact with the app, including zooming and panning and exploring values via data tips. And you can brand your app as we did, using a custom logo. Now you can share those apps directly with others, either to run from within MATLAB as standalone desktop apps, or as web apps that are accessible via a browser.
You can create apps, web apps, and FMUs from models too using Simulink Compiler. Some of the latest updates include automatically generating a MATLAB app for your model and including the source code in a co-simulation FMU for working across platforms. There will be a session on sharing MATLAB applications and Simulink simulations, so be sure to join that to learn more. Another key step in taking your ideas to production is automating code generation from the work you've already done in MATLAB and Simulink. You can take the auto-generated code and integrate it with existing software frameworks or deploy it to hardware. MATLAB and Simulink give you the capabilities you need to take this step, whether your hardware is for production, rapid prototyping, data acquisition, or just low-cost hardware. There's an option for everyone. All right. While we couldn't show you everything, hopefully you saw some new capabilities in MATLAB and Simulink that will help you with your projects. Perhaps it was one of the new capabilities for helping you focus on your work, or new tools and interfaces for collaborating with others, or one of the paths for taking your ideas from concept to production.
You can explore these new capabilities using MATLAB and Simulink online. These always give you access to the latest release, so you can try things out without having to download or install anything.
So, while this session is drawing to a close, there's plenty of opportunity in these 2 days to learn more from your colleagues, see more details on what's new, and find ways to apply MATLAB and Simulink to your own challenges and opportunities. Check out the agenda. There are sessions across multiple tracks covering AI, autonomous systems, modeling and simulation, and more. We'd like to thank you for your time.
And enjoy the rest of the conference.